Number 13 is a complete grab bag. You could go any method you wanted to go here, okay? If you wanted to go elimination method, you'd move the 9 over, and then you'd have these in standard form, almost standard form. You'd have to do a little rearranging, okay? If you wanted to graph them, you would just solve them both for y, not as hard as it looks. If you want to do substitution, you would isolate a variable, okay? In this case, I would go after this x variable because it does not have a coefficient. And then you would plug that into the original equation. So this really is whatever method you would want to do. I probably wouldn't advise elimination, not that you can't get the problem right, but I probably wouldn't advise it just because a lot of people have a tough time writing stuff in the correct order and manipulating things and all that jazz. So I'd probably either go substitution or graphing. We haven't done a graphing problem in a while, and I kind of want to example to people the fallback here is graphing, okay? But I'm going to do one I already see later on. I'm going to do 2. So I'm going to go with substitution here, okay? I think graphing is going to be most people's best bet because you just solve for y. And we're really good at solving for y. So when you get onto this section on the test, if you blank out, if you forget all these other methods, know that if you can solve for y, you can get all of these answers because then you're just graphing, okay? But I'm going to do substitution here, and I'm going to attack this x variable like I said. So step 1 of substitution, okay? Step 1 is isolate any variable. So if I add 9 and subtract 3y from both sides, I'm going to have x all by itself. So this would be negative 3y plus 9. Okay? So if I know what x equals, I can take that information and plug it into the original equation. So my new equation is negative 3y minus 5 times x, but I know what x is now. It's negative 3y, again, plus 9 equals 3. Whenever I start working this problem out, I have negative 3y plus 15y minus 45 equals 3. We're talking about this couple problems, last problem, 2 problems ago. Okay, 2 problems ago we were talking about this, sorry. And we're talking about how, like, hey, if things aren't going right, start checking some of your math. Right now in my head, I'm already sitting here thinking, this isn't working out right. But I'm going to carry it out to the end. It's just in the back of my head. Maybe that's just doubt creeping in from 2 problems ago. But let's keep on going. Okay, this is a 12y when I combine like terms here. And I'd be adding 45 to both sides. Okay, that means I'm going to cancel here, but I'm going to get 48 here. And I kind of breathe a sigh of relief because by my 12 times tables, I know that y is going to equal 4 now. Okay, that's that division. I take that and I plug it into one of my original equations. I kind of marred through this one a little bit. So you can either use this top one or you can use the one that you created here. I'll do that now. I get x equals negative 3 times y. Well, y is just 4 plus 9. X equals negative 12 plus 9, meaning x equals negative 3. So I get negative 3, comma 4. Number 14 is very similar in the sense that it doesn't really look like it's going to have a pretty way to solve it. Okay? Graphing means I solve them both for y. That doesn't look like the end of the world, but like, great. Okay? Substitution means I got to solve for a variable. That looks terrible, so I definitely don't want to do that. Elimination means I kind of just got to rearrange stuff a little bit, and I think I'm going to go after it with elimination. Okay? So to get elimination, I need all my x's and y's on the same side together. And then I need them in the right order. For this top equation, that's going to be a little bit difficult. So it's 12 plus 2x equals negative 3y. I would add 3y to both sides while subtracting 12 from both sides. I'm going to write the 2x first because that's standard form. Okay? That's my top equation done. My bottom equation, I need to write these in a different order. Okay? I need to write them in a different order. But I also need to subtract 12 from both sides. When I write these in a different order, their signs stay with them. This is negative 2x minus 3y equals negative 12. okay? And now I'm ready to kind of line these two up. So I'm gonna take this equation, I'm gonna transpose it over to here. I get negative 2x minus 3y equals negative 12, okay? I'm gonna add these together. When I add them together, my x's cancel out and my y's cancel out, leaving 0, all right? But then on the right-hand side, these do not cancel out. I know a lot of people get cancel happy and they're like, oh, cancel. That would be a negative 24. 0 does not equal negative 24, and thus there are no solutions to this problem, okay? Number 15, this is the one I was looking ahead earlier and seeing that I saw one already that I knew I was gonna graph, okay? Because I'm just gonna solve both of these for y. For this top equation, 6y equals negative 24 minus 21x. That means I'm just dividing by 6 and dividing by 6, okay? This is y equals, that's gonna be a negative 4. Then I look here and I'm like, wait, hang on. How's that gonna work? And if you wanna do all the fraction math in your head, that's fine. But I look and I say, okay, negative 21 divided by 6. That's ugly. But it's in front of the x, which means we're gonna leave it as slope. So I press math, turn it into a fraction, I get negative 7/2. Okay, still not pretty, but I would rewrite that, however, into negative 7/2 x minus 4, just to have it in slope-intercept form. For this second equation, all I have to do is subtract 7/2 x from both sides. Okay, so when I do that, I get y equals negative 7/2 x minus 4. And I go to graph both of these equations. Most of you can probably already see what's going to happen. Okay, I get negative 7/2 x minus 4 and negative 7/2 x minus 4, and I press graph. Here comes my first equation. Here comes my second equation. And we can see that they just lined up right on top of each other, meaning this is infinite number of solutions. I wouldn't expect as many problems like 14 and 15 tomorrow, just because I'm gonna probably lead you a little bit more to the water. It'll be ones like the first couple in the section where it's clearly in standard forms, should immediately tell you to do elimination, or they're both, like number 16, they're both solved for y. Anytime they're both solved for y, you need to know, graph it. Or if you just want to solve them both for y, you still means you would just graph it, okay? So our first equation is y equals x plus 4. Our second equation was y equals negative 6x plus 11. And we graph it. It's a good opportunity to review how to find an intersection on a calculator. This looks like it's at like 1.5-ish, but I don't want to leave it to chance. I second trace to find my calculate feature. Do number 5, enter, and it tells me it is in fact 1,